Hey, this is Mrs. Pound here, and we are on our second, still the first section of the second chapter because yesterday we talked about some characteristics of matter because we're in chapter 1.2 about the nature of matter, and we're talking about the characteristics of matter. And one of the characteristics we talked about, or I introduced yesterday, was density. And we talked about that there are non-characteristic properties of matter. They are characteristics that we cannot use to tell what it is, what the substance is. And then there are characteristic properties like density that we can use to tell what a substance is. And the funny thing about density is it actually uses two non-characteristic properties to basically create a characteristic property. So let's take a look at how that works. So our objectives today are to correlate the terms mass, volume, and density and calculate the density of a substance. Density from yesterday is the mass per unit volume of a substance. So what does that mean? That means it's basically an equation. And the equation is density equals mass over volume. I wrote it in words for you here. And in symbols here, D equals M divided by V. So density, I said, is a characteristic property, but look over here. Mass and volume are non-characteristic properties that are used to find density. The units for density are grams per cubic centimeter or grams per milliliter. It's basically mass divided by volume units. One important fact we need to know is that the density of water at 20 degrees Celsius is 1 gram per cubic centimeter. Always. That's the value we are going to use for the density of water when we make comparisons, because we can figure out if something will sink or float in water if we know its density and the density of water. Now, if a substance has a density higher than water or greater than water, it will sink. An example is iron. If you put iron in water, you know that it sinks. Therefore, its density is greater than 1 gram per cubic centimeter. If a substance has a density lower than water, it will float. Some examples are most woods and most plastics. And I say most because there is at least one type of wood that I know of and one type of plastic that will sink in water because their density is greater than that of water. Now, you're going to be doing some problems. We're going to be doing this in lab and we're going to be practicing in class. So I want to run through how to do some problems with you. So you'll see here I have the problem. Let me get my pointer. Oh, yep, right here. So here I have the problem at the top. I'm going to keep that problem at the top. You don't have to keep copying it down or anything. I have it there so we know what numbers we're going to substitute in. And so the problem is if the mass of a block of wood is 20 grams and its volume is 25 cubic centimeters, what is its density? So our equation, we always start with the equation. Always write down your equation. Okay, don't skip that step. So I wrote down my equation, D equals M divided by V. Then I substitute in my numbers. My mass number is 20 grams. And my volume number is 25 cubic centimeters. So 20 grams goes on the top, 25 cubic centimeters on the bottom. Then I do the division. And 20 divided by 25 is 0.8 grams per cubic centimeter. Now notice G divided by cubic centimeters, just like in the equation. Okay? And I also made a note that the block will float in water because its density is less than 1 gram per cubic centimeter. 0.8 is less than 1, so it will float. Let's look at another problem. Now this one involves another step, because it says a piece of wood measures 5 centimeters wide, 5 centimeters long, and 1 centimeter high. It has a mass of 30 grams. What is its density? First, we have to find the volume. And remember from math class and probably past science classes, volume equals length times width times height. We substitute our values in. I have volume equals 5 centimeters times 5 centimeters times 1 centimeter. That, when we multiply it, 5 times 5 is 25, times 1 is 25. That comes out to 25 cubic centimeters. Now that I know my volume, I go back to my density formula, D equals M over V, because I'm given mass in the problem. I calculated my volume, so now I can find my density. So I put in density equals 30 grams from up above, right here, divided by 25 cubic centimeters, which is what I calculated for my volume. When I do the division, I get 1.2 grams per cubic centimeter. Now, this block will sink in water because its density is greater than 1 gram per cubic centimeter. So our objectives for this section were to correlate the terms mass, volume, and density, and we did that in an equation, D equals M divided by V, density equals mass divided by volume, and to calculate the density of a substance, and we learned how to do that. We're going to be practicing that in class with a worksheet, and we're also going to be calculating the density of many objects in lab. Now don't forget to write your 5 questions.